All right. Hello, everyone. My name is Ashish. Welcome to this session. The focus is primarily on this framework called FlexTest 2.0 that we have developed using Actor Framework. Uh, the primary presenters are Akshata, Matt, and myself. Um, and the agenda we have is Akshata, can you go to the next slide? Yeah. So it's a brief agenda what we have. We'll give a quick introduction about RF systems and Bradley technologies. Then Matt will kind of give you a history about FlexTest, how it all started, and you know what challenges he faced, and why we have this FlexTest 2.0, and how. And then later Akshata will take it forward to all this design process or the development process we followed in developing this FlexTest 2.0. We will have an actual real example from a customer that we will showcase, and we'll specifically focus on how this um, exercise of upgrading to 2.0 and using actor framework really made a big difference. So we'll have some of those points touched, and then Akshata will have a nice demo about how or different features of this framework or the FlexTest 2.0. Okay, let's go to the next slide. All right, a bit about RF systems. Um, we are an application engineering organization, globally recognized by customers and partners for excellence in service and automated test solutions. We are now 11 years old, started in India, and now we are actually in California as well. uh, our primary focus is to provide the best processes for software development of test and measurement solutions. I want to emphasize on the word processes because um, being an engineer, going through all this last my experience with LabVIEW. um, at the beginning you start as an engineer doing some lab view coding as things start working, but then you make a small change, things break, and as you mature over the time, you get more responsibility of bigger projects where the process plays a very important role. So we try to focus ourselves to make sure we have nice process that a team follows while we develop the solutions for customers. I try to emphasize on our core values. These nine core values are something we try to follow. I'll say try to because it's not always possible to, it's difficult to follow all of them all the time. But these guidelines have kept us going for last 11 years successfully. Some of them most of them are very common in the sense you can apply in personal as well as professional life, and just wanted to emphasize how serious we are about them. Yeah. So can you go to the next one? A bit about myself. So I did my master's from Oklahoma State University. I got hooked to LabVIEW during that time. We had a NI had sponsored some hardware to the college, to the school, and I got to play with the project for balancing an inverted pendulum. It is a classic academic project, but it really got me hooked to LabVIEW, especially being a mechanical engineer interested in robotics. I realized, this is what I really love, enjoyed doing, and that's been what I'm doing for last 20 years. Started as a junior engineer at JKI, and uh, went back to India, and now I'm back to USA. So it's kind of an interesting last, 20 years experiencing, getting experience in the Bay Area, setting up RO systems in India, and then trying to expand by being back to USA. And I guess I'll say the best part about LabVIEW was it really got me connected with some very nice people, honestly. And I realized that all people doing LabVIEW are good people. That's kind of my broad experience is telling me about. An example is, now the presenters like Matt and Akshata, the kind of reason the most common thing between us is LabVIEW, other than, being good people. So that's in a very broad sense. I'm very happy about, my experience with LabVIEW. And it never failed me. Um, so I'll say that's something I want to give a message to everyone. right? Akshata, can you go to the next one? So yeah, our giants are female also, and one of them is Akshata. You know, and honestly, we had been uh, having female participations in all front of life, at professional and personal level. But I want to emphasize, it's hard to underestimate their contributions at different phases of life. And Akshata is one good example in our team. The way Akshata was passionate about progress in her professional life. Akshata had shown her capabilities by she had a fellowship during her school or a study time, which was more like earn while you learn. And then if you want, she can provide more information about it as we go proceed. But definitely, Akshata is now a senior system engineer with us, and we are very proud about how sincerely and diligently she has taken over, stepped up, and uh, took some responsibilities in the team. Akshata, you want to say something about the fellowship you had?
Yeah, so the fellowship is actually no, it's equivalent to, or the more to engineering degree whatever we get. So it's a 5 years course basically, and we get all practical learning throughout our journey, and we will have an internship with our the course, and we will have our degree done with any open universities. So it's really helpful for the students who wants to be in a technical field and who has a the financial issues.
Hmm.
So it's, yeah.
Yeah. Now that, and I guess that level of maturity, or I mean, I just want to say, highlight that Akshata is a very crucial member of the team, and I'm proud to showcase her as our giants are female. So yeah, Akshata next. Yeah, now I would like Matt. Why don't you give a brief intro about yourself, and we
All
can take
right.
it forward from there.
Well, I've been doing this for 28 years. Before that, I was actually on the faculty at Penn State University, if you can believe that. And I've developed a very strong record of developing, dramatically reducing testing times and improving product performances. One of the early ones I did was actually on the Motorola StarTAC phone, if you remember this one here. Tripled the production rate on it. And basically been dedicated to making sure our customers are more than just happy. A certified LabVIEW architect. Also do a lot of work in Python and some firmware development. I've worked in a variety of different industries, but the primary ones have been RF, telecom, fluid mechanics, and medical devices. And there's a good amount of overlap in some of those. Some of my past clients have included Lockheed Martin, Cisco, Agilent, which is now Keysight. I've done some work for National Instruments. I'm particularly proud of that. And Ritsu and LightPoint. And there's a lot more companies I've done. If you ever want to see my resume, I list them all, and it's a long, long list. Okay, next slide. So what I was after working in this for about up around 2010, I think, I realized that I was having some trouble with RF testing because what I wanted was a LabVIEW GUI that could be used for multiple purposes. One is for validation and verification when the engineer who designed it is working on it and wants to see that it works, that everything works correctly. If it's brought back, they want to look at it for debugging and repair, maybe some light manufacturing. But I wanted to have the tests themselves to be compatible with test stand so that I could run all the tests from test stands in a given order. But for my LabVIEW GUI, I could move around to whatever test I wanted, run it as many times as I wanted. If I'm doing tuning, I could be tuning it, running it continuously, things like that. And after thinking about it long enough, I decided to make my own. And there's two parts of it. One is the GUI, and that's what we're going to focus on right now. And that is how the tests are controlled and how we flip back and forth between tests. The other part is the instrument drivers, and we're not going to talk too much about that today at all. But that is a very big part of it. The reason we're not going to talk about it is because when we went to develop 2.0, we're developing it in two parts, and the instrument drivers is the second part. So this was targeted and particularly for RF tests and especially in the case of the instrument drivers for RF instruments, but it's not exclusively. In fact, right over here, I've got a test running using FlexTest 1.0 for a medical device company. So we've done a number of projects that completed using this since I started developing it. One was for Lockheed Martin, an RF project. One was this medical device company right here. Another is a startup company called Zanar. And we've also done some work for a little company you may have heard of called National Instruments. And that was an RF test project right there too. Next slide, please. But what I realized is as some of these tests got bigger and bigger, particularly, for example, at Lockheed Martin, I realized this, that there were some very real limitations because the whole test itself is based on a Q-based state machine. And I realized that I was going to have to do something entirely different because it was just, it just got to the point where it was too difficult to do a lot of development fast like I had envisioned. So I came up with a new design that would use actor framework for a much more scalable solution. And for the instrument drivers, and this is probably the last we're going to hear about them, is go more to an object-oriented instrument drivers than I had in the previous version. The problem I had was that FlexTest 1.0 has been keeping me, particularly, very busy over the last several years, which is a good thing for my bank account, that is. But to do this for FlexTest 2.0, it was going to involve a large-scale rewrite, and I tried to start it a couple times, but quite honestly, I would just get too busy, and nobody that I had working for me really had enough time to work on it. And along came this project from one of our new clients, Esperanto. Now, it's the perfect project for developing this 2.0 version because FlexTest 1.0, as it turns out, would not have been a good choice because of all those reasons, all the limitations that we saw in FlexTest 1.0. And the other reason is because we could do it without working on the instrument drivers, which I said we weren't going to mention again. I lied. But I still had the problem of I don't have the time to do it myself, do the groundwork. And that's where we ended up teaming up with Ashish and Arav Systems through a mutual acquaintance who was able to set us up together, and it worked out perfectly. Next slide.
Yeah. So thanks, Matt, about giving the introduction and the motive about the FlexTest 2.0. So yeah, when we decided that we'll be starting with the FlexTest 2.0 using actor framework. So first we started with having a design done. So we started with a class diagram and a sequence diagram. We made use of it by using UML diagrams, so that that will help to decide what are the object blocks we need, how our framework or application, the hierarchy we define. So this is the example class diagram which we created. Here you can see we have divided into two parts. One is a FlexTest and other one is a Esperanto. Esperanto is our client and it is our application. And in a FlexTest is a framework where we have defined all the classes where it will have a abstract classes defined. So for the example abstract FlexTest app, which is like a master to handle all other actors like test cases or panels and the sequencer. And the same way we have a Esperanto AI, which where we will have all the panels, test cases, the classes related to the application which we have defined here. And when we move to the sequence diagram, so we have defined a sequence diagram which will help to define the flow of the each execution, like when we have defined the different classes, or the communication will be, what are the steps will be, how do we communicate, and what data we use, like the whole API, the everything, the messages, methods, how do we communicate, everything we have defined in the sequence diagram. So this is how we approached we made use of class diagram and the sequence diagram, and we defined our the whole design process. And next, we have defined 6 layers in our architecture. The first layer is the application layer. So we have Esperanto in our main actually, and we have all user interactions, all the communications defined in the application layer. Next we have as a framework. So framework is FlexTest 2.0. And third layer is the application programming interface, where we are defining all the APIs to communicate between the applications framework and within the framework and within the application. And next we have a abstract layer. We have defined all our abstract classes in this layer, which will useful to communicate. And then we have a drivers. Example, we have a AdLink, iBoot, TCU, and other drivers. So we have created a drivers instruments for each. And next we have a physical layer. Physical layer is actually the bottommost layer, and here we have all the hardware's network devices, which is defined here. So this is how we have defined the different layers of our architecture. And like we have created drivers such that it will be used as a plug and play instruments. So for example, if you take as I mentioned before also, the like add the DAC driver. So DAC we are using as a AdLink DAC 2205 for our application, and we have created abstract, the simulation and the concrete class created for it. And as we are making use of actor framework here, so we have created a control panels. You can see the power control panel, which we made use of actor framework. And which will be we can show the panel, the control panel, for how by making use of this methods, the communication, whatever the data is acquired, that can be shown here. And the API, like we have defined the API such that it is easy to communicate, integrate, and easy to maintain. And whenever there is any new changes has to be done, that can be done very easily by just changing, modifying the APIs. We can easily interpret into our application. We don't have to do method modifications or rewriting the code. That can be handled. The next comes the framework. We actually divided our code into two parts, like two different repositories, one for application and one for framework. Framework is a submodule of application, which is very useful for a developer to develop it independently. Like we don't have to depend on any other developer while developing or creating a framework or working on applications. And we are making use of Jenkins for using a continuous integration. So whenever we commit some or push to a bit so it will actually do the build and it will do the test, and when there is no changes, I mean everything is fine, then it will go for a release. We have configured Jenkins such that there is any particular changes done in a particular defined branch, then it will be considered as a release. So that is how our repo management time is done. And next comes to the advantage, I mean actor framework advantages in FlexTest 2.2. So like we know, like actor framework has many advantages. Like it is one is like a modularity. So it gives a more modularity where we will have a minimal coupling when we'll have to do any further changes. Okay, so whenever we are doing code modifications, so it gives that. So in FlexTest 1.0, when we were using a cube-based state machine, so whenever there is some changes has to be done, that was not easier to do any code modifications or the optimization. So as we are using actor framework in FlexTest 2.0, which is helpful in doing any code modifications, and it will supports any kind of the changes. And we have a feature for configuration compatibility. So we are giving a flexibility to have multiple versions of a framework or the applications handled. So we have created a configuration for whenever we configure some test panels or the sequences. So we create a different configuration. So whenever there is some changes we are doing or any features we are adding to the particular function, so our configuration data will change. So by making use of this, right, so it will helpful to handle the multiple versions of the multiple versions. And we have a feature like the result on the abstract result logger we created, which will help to log test results or any particular test information, or we have a room to add a error logging feature too. And actor framework is a scalable and extensible, that we know, like we can uh, add any part of the code easily in case of any changes we'll have to do. And it will easily adaptable for the new changes. If we have to create a new driver, we have created a new class that can be easily, we can integrate by defining a readable or adaptable APIs. And we have this control panels created, so the drivers, so we can, as we have defined the abstract class and the simulation class, so we have defined the DAC 2205 as a concrete class. If we have a different instruments, so we can easily incorporate, we can just have to create a concrete classes for the each driver, so we can make use of the same abstract and the simulation classes. So that's how, like, it's easily adaptable to the new instruments or new class or new feature whatever we add. Yeah, so we have a actor framework gives a reusable method. Like in a common feature is like actor framework, whenever we create a classes or actors, right, uh, we can inherit the properties. When we create a child class, we can inherit the whole methods and the whole properties defined there. So what we have done is, like, in a framework we have created the all abstract classes, like abstract test case and abstract panels, and we have defined the common functionality or common methods required for different test cases which we create. So whenever we create a new test case, we just inherit it from the abstract test case, and we get all the methods properties created. And we have one more thing, like, we have created templates for a test, like all the minimal UI and the minimum communication through to the framework, everything is defined already in a template. So whenever we gonna create a test, we will just clone it from the template class, so it will actually incorporate all the properties what and the UI methods created in the template. And our FlexTest 2.2 framework is also very reusable. In case of the similar to our application, if we have a different application, we can usually make use of our framework. It is like a plug and play, like as I mentioned, like a not just a driver. Our framework is also like a plug and play. We can just make use of our framework into our different applications too. I mean, similar applications. Active framework gives a advanced feature, like it supports the asynchronous call, like a parallel execution. And it actually we can run a multiple instances of a same actor, like it will work as a clone mechanism. So in our application, right, we have a test created, and we can create a copy of the same test which will work independently without having any issues. So example, if I had to take in a screen, right, so I boot main toggle is one test defined, and I boot on and I boot off. I have created a two test underneath, and first one test when I run, it will turn on the iBoot, and the other will turn off the iBoot. So same way, like we can run the whole application parallelly. So there will be a different modules defined, which will work parallelly. Like one is, if I have to take a DAC, the data is acquired, so it will send to the calculation actor. So that will do the calculation. Then it will go to the sequencer, and it will update the result on the panel. So everything will be done in a parallel. And the main framework features are, like, we have a control panels, we have a test step creation, and we have a sequence creation and the result log. So these are the, like, main strong features of our framework. We can see all these features in a demo. Okay, so this is our application, and here we have a panels. Can see,
Akshata,
yeah.
we just see the demo slide. We don't see the.
Oh, okay.
Maybe you are sharing only the browser, not the screen.
Uh, okay, I'll start sharing.
We are
Okay.
experiencing technical difficulties. Please stand by.
There you go.
Yeah. I've just stopped and shared again.
Okay.
Okay. So this is a demo. I mean, our application window. So here we have defined different control panels. So each control panels are created to test each individual, the instruments or driver. Example like a DAC power control panel. So here we can see a different windows, and when I click on a start, here we have all channels listed. When I select one, so it will actually show the average power calculated for the selected power channel. And we have a gauge view where we have displaying the cumulative voltage and power data. And we have a capture view where this actually helpful when we want to capture or select. Here we have a feature like we can select all power channel or select any particular channel, and we have a feature to log this particular data. And we have a monitor window like where we are getting all total consumption of power. So we have a TCU control panel, QART, PMIC. So PMIC, right, like when we have a device called PMIC and we have a DAC. So when we read the data, so it will actually get the data from PMIC and DAC, and it will compare and give the absolute difference. So we have a feature to write some value to the uh, device. We'll get a confirmation text there. And we have a iBoot control panel where we are making use of this to just to control the power supply to the other devices. We can turn on or off individual channels. And here we come to the test cases. So we have a number of tests already created here. I'll just show like how we create. So we have an option, and whatever the test we have already created and added to the software, so which will be listed here. We can select any of it. I'll just select read DCID. And when I selected it, its actor is launched, and we can see the control panel here. So when I run it, we can see the result of it and shown here. Same way we have a different test created like NST. NST we mainly using for the sweeping test like for frequency, voltage, mean and share for different parameters. And next we have as a sequencer. So sequence is a combination of we can have a combination of all tests or or selective test. Instead of executing the individual test, we can have a set of tests configured in a sequence which will execute and gives the whole result of it. So when I execute the DAC test, it's running individual test by test. I boot on, then it will collect the data. Now it's going to I boot off. Once the test is completed, it will log the data and it will give this result. Can show you how the results will be logged also. Yes, this is how the result will be logged. Okay, so this is how I have created a different sequences and configured. So it's easy to create a sequence. Whenever we click on a right click and create a sequence, we can just enter a sequence name. And here we have a 3 different paths like a setup, main and cleanup. So here we can see a different test cases created. And here we have one more feature like, we can have a multi-test sequence. So we can create a sequence of the sequences. So this is also a feature we have. And I just selected one test. When I execute, it will just give the result out of it. Yeah, special thanks to Esperanto. Like we have developed our application for Esperanto, and they gave. They're okay with to use the data and information about it. So that's why, we are thankful to Esperanto AI.
Yeah. So Esperanto, all the examples or the demo that you saw was the actual requirements from Esperanto, and according to their requirements, the test cases, the data to be collected, the reports or the logging All those
Mm.
features were custom created for Esperanto, uh, and the panels arrangement, the framework is FlexTest is still at the bottom of it, uh, but that whole thing is customized based on the requirements from them. Um, and similarly, depending on the new requirements, the panels can be made. The logging can go up to, like, internally back in the backend it is LabVIEW, so we can do up to database or logging on the cloud and things like that too. But yeah, we really appreciate them allowing us to use the actual product or solution we are developing for them.
Yeah.
Yeah, I guess. Yeah, go ahead, next slide, Akshata. Yeah,
Yeah.
so guys, any questions, feel free to ask. I do have some questions I would like to ask, like a poll to the audience, but I didn't get it. I could not set up the poll. I don't know. Maybe I don't have permission. So while you guys are asking some questions, maybe in the chat, um, I'm wondering if you guys use a UML as part of your software development process. Uh, you know, just curious about if you guys use UML. You can reply in the chat. I'm interested to know. Uh, Another question is, do you guys use Actor Framework or any other framework from NI or from third party, um, that you are aware or that you like? And there is a continuous integration. How often do you use it? If you're not, then just want to know. So if you have those answers, yeah, please reply on the chat. I'm curious to know. But otherwise, that's the contact information. Um, and yeah, we'll keep the session open for maybe another 5 minutes or so. If anybody has any questions.
Yeah.
By the way, good work, Akshata.
No. Yes, very nice.
Thank you.
Also, one thing I like about the way we've done this too is using Jenkins to continually test the software. I've used Jenkins on a number of different projects, other places, but this is the first thing that time I've ever used it with LabVIEW, even though I've wanted to.
Oh, okay.
I think that's definitely a selling point to make sure about the software quality and the, that just to make sure that everything works.
Yeah, and more team members involved. It's important to make sure we know where it breaks
Yes.
before it's too late.
Yeah, the more people you have involved in a project like this, the more things can break because people don't
Yeah,
understand or
correct.
something.
Correct. And that's why I was emphasizing on the process part,
Yep.
because that's something we're really proud
Yeah,
of.
that's exactly right.
Yeah.
Because I think tools like Jenkins are very important when you get to larger scale projects.
Yeah, true.
Okay. Thank you, Mangesh.
Yeah, thanks, Sriram Mangesh.
Thank you.
Thanks for helping with this presentation too.
Anyway, we have plans to use FlexTest 2.0 and a bunch of other projects. So
Yep,
we're looking forward to seeing where we can go from here with this.
true.
Okay.
Okay.
Oh, it was missing in chat. Okay. Thank you, Christian. I guess we just explained everything so well, nobody has a question.
Good. Yeah. All right. I think we should be okay to. I hate the long silence. So, and I think,
Yeah, I think
right. I think we are good.
Yeah,
So
that's one of the problems with doing remote with these kind of things is we can't get the feedback from the audience. That so much easier when it's live.
yeah. Oh yeah. Definitely. I mean, we are all learning from it to how to be more interactive.
Yeah.
But yeah. But I guess so. If you guys have more questions, feel free to reach out to us.
Yeah.
I think this recording will be available for people to watch later.
Okay.
And I would like to know how you feel about it. Any feedback you have, would like to be in touch. Okay.
Thank you very
All
much.
right. Okay, guys.
Thank you all.
Thanks, Akshata.
And thanks to GLA organization for giving us this opportunity to present.
Oh, that's
Thanks.
true. Yeah, and definitely, yeah, you're right. We should definitely thank them for organizing this. At
Yeah, they'll have it on YouTube at some point soon.
mhm.
Yeah.
Oh yeah, so Christian is saying, yeah, YouTube at some point soon. Unknown. Yeah, okay.
All right.
Yeah, but yeah, so we'll everybody will get that information about the recordings. In fact, we have to watch some other recordings that we missed. So even everybody is looking forward to them. Thanks, Christian, for the information. All right, guys. Thanks a lot.
Thank you so much.
Thank
Bye
you.
bye.
Bye.
Yeah. Have a good day. Bye.